welcome to the demonstration of unified testing framework for RouteFlow. This work is basically done as a part of Google Summer of Code program 2015, and the current work is available on GitHub under this repository. So the work basically comprises of implementation of test cases along with the test framework. So the testing framework is completely into test_rf.py file, where it deals with knowing the health of RouteFlow components, also extending the test cases with ease at faster pace. The dependencies for test cases to run is a Linux 3.5 or 3.8 generic kernel on Ubuntu 12.04 machine. Basically, the building steps are still the same, wherein we have to build using a build script which is already available. Now, to run the test cases, we have to first run the components of RouteFlow. Other than OpenVSwitch, everything is fine, and to run OpenVSwitch, there is a script that is introduced. Credits to Rafael for doing this. Now, to run the test cases, first we have to run a pre-implemented test case that is already available, and then we have to run our framework. This will indirectly run all the test cases and generate the results. The results will be available in the same directory under rftest.log file. In order to extend or implement new test cases, just follow the following steps, and it is straight, easy 5-step procedure which will not take more than a day or two to implement any new test case using this framework. So the one problem which people face is RouteFlow is currently not running on 3.5 or 3.8 kernel. It is currently running on 3.2 kernel. So for test cases to run, we have to update to either of these kernel, and it is currently tested on 3.8, that is Raring kernel. So coming to the current issues that are available, although the logging framework is implemented, we can see the results only in rftest.log. This should be resolved. As in, the connectivity test is available, but still a minor glitch is yet to be resolved. As a future task, we still propose, instead of using argparse module, we can implement a JSON parser and consider writing all the test cases in one single JSON parser, in one single JSON file. So let us go to the demo of it. Here I am currently running the test rftest1 test case. We are in the test directory, and we have connectivity, containers, Mongo, OBS, RF apps, and test_rf. This is our framework. Let me take a moment to explain the framework first. So the framework has basically tests as a first class, which has a catalog dictionary which consists of key value pair with the module name and the class name. So we will fill in the tests to run. This gives us an opportunity to run individual tests which are required. If we want to run only OVS, we can mark OVS as true. If we want to run only containers, we can mark containers as true. Coming to the configuration parameters, if we are to check whether MongoDB is running on a particular port, or if we are to check feature RF client is running on particular containers, we have to set these parameters. there are functions which will set these variables, and these are the functions: set test run, configure test, set test output format, set test output modes. And setup is the function which will set up our logging server, and it has handlers for info, debug, and error logs. Now coming to the framework, the first major function is find tests, where it will walk through the directory and find all the modules with test underscore, which is the implementation of individual test cases. Then it will match the test case class within the catalog and create objects for the classes. Using the created objects, which the objects will be stored in setup test dictionary, and using the created objects, run tests will be done within the run test function. Coming to the running of test cases, each test case class has a run test function which is inherited from RF unit tests, and the run test basically add the test cases required and then calls the evaluate, verify, and analyze functions of run tests in the base class RF unit tests. Sorry for that. Coming to RF unit tests, we have our constructor, a user defined find function which is required in the test underscore connectivity class. So the user defined find function will search for reachability or packet loss in ping and report results and returns true or false. The evaluate, verify, and analyze functions are implemented here. Now I'll run the test cases for you. Running test cases is just one command and it will produce RF log where all the results are stored. As in when test MongoDB class searches for MongoDB port running, since this is not the port on which it is running, the test case failed, and RF server is currently not running. OBS is running and DP0 is available, test case is passed. RF client is currently only running an RF VM1 and not in B1, B2, hence RF VM1 passed. Rest of the test cases failed. Coming to containers class, this test case is only to list down the current state of containers, and these are the containers that are running as a part of RF test 1, and this is the result. RF proxy class, and these are earlier results. So running the test cases is just one command and results can be checked in rftest.log. Thank you. This is the end of demonstration.